So yeah, today I'm going to be going through what is secure coding, why it's important, what types of attacks there are. We're going to have like a brief overview of some of what I think like the low-hanging fruit of like really easy ones to sort of solve in your applications, and then give a quick demo of a few of them and explain how they relate to like modern web applications. Yeah. So firstly is what is secure coding? So secure coding is writing software so that it will be able to maintain all aspects of CI triad, which is this nice triangle here, which I'm sure anyone that's looked at security before has seen. So you want to maintain confidentiality, which is ensuring data is only accessible by the correct parties. So that's ensuring that, yeah, if it's your data, only you can see about data. A hacker can't get into the database, they can't intercept your request to the server and read things that they shouldn't be. The second part is data integrity. So that's ensuring that data is correct and can't be altered by a malicious third party. So if someone gets access to the database and is able to change values, that's obviously breaks integrity. And yeah, editing requests, that kind of thing, would break data integrity here. And the third part is availability, which is data should always be readily accessible. So this is ensuring that, yeah, preventing denial of service, making sure that your servers are always up and available for whoever needs it. And how we maintain this is by ensuring that our code is free of vulnerabilities. So why is this important? Well, the global cost of cybercrime in general is $6 trillion every year. The average cost of a data breach is estimated to be $4.35 million. And yeah, this graph is from IBM. They do like a report every year on how much a data breach costs on average. And you might think this is like, you know, really high for a company like us, but if you consider the kind of clients we're working for, if we had a data breach on one of our major clients, you know, that's going to be really costly for them in terms of both reputation and like customer trust, as well as just any like regulatory fines, especially in like finance industry and things like that. And also, you know, if we're responsible for one of like the major like hacks in the future, that's going to reflect really bad on us as a company. I imagine if you Google Theodo and the first thing comes up is that we're responsible for one of our major clients having a data breach, we're probably not going to be getting much business. Yeah. So, yeah, so this is a little case study that I want to go through just to show that how wide software vulnerabilities can impact. So I don't know if anyone remembers this one. It was probably like last year. I went back to fix it for one application or like patch the library anyway. So it's the log4j Java library. So this was a very widely used tool in Java, which allowed you to just, I can't remember exactly what it does, but it's just used in logging a lot. And the vulnerability allowed for remote code execution, which means that a malicious third party could run any sort of Java code from anywhere on a system running this application. And I mean, once you've got remote code execution, you can pretty much do anything you want to a system. And yeah. So the way it works was it used substitutions in this form with prefix :name to allow the strings to be generated into the logs. But they also allowed JNDI objects to be fetched using LDAP, which is sort of remote fetching library, as far as I'm aware. And basically, you could put your strings or code in this case on just any website, for example, example.com/file, and that would be fetched and then run using the log4j library. This affected really big companies like AWS, which obviously runs a lot of the stuff on the internet, VMware, and I think most importantly for us, Minecraft. Yeah, I read a stat somewhere, I don't know how accurate this really is, but it said that 95% of Java systems use log4j directly or indirectly. So this vulnerability was around for a long time and wasn't protected and affected 94% of Java systems.
In fact, we had to deal with it on our project as well.
Yeah. Okay, so this is a list of the most common / like most important vulnerabilities. It's called the OWASP Top 10. So we have on the left 2017 ones, and then they refresh it every like 4 years, I think. So to get the new list of top vulnerabilities that we should be aware of. There's like a big document on the OWASP website, and you can just sort of go through and explain how they work, give examples, and then they also give you ways that you can fix it, which includes like patches for software, as well as like tools to actually detect it. And there's loads of really cool stuff in that. So today in particular, we're going to be looking a bit into a few of these. So we've got 2 injections that we're going to be looking at. So both cross-site scripting and SQL injections. And then we're also going to be looking at CSRF, which isn't on it, but I think it's quite important. And it's sort of similar to SSRF, which is the bottom of 2021 list. So yeah, one of the first vulnerabilities is outdated dependencies. I think it's quite an easy one to get started with because it's quite easy to fix. There's a lot of tooling online. So for example, like npm audit, dependabot, or OWASP dependency check, all like tools depending on like how detailed you want to get into it. So you can see here, like bottom left, is just a result from npm audit displaying like a list of vulnerabilities, and above that I'll have like all the vulnerabilities and link them to CVE, which is a database of lots of vulnerabilities and sort of like, yeah, when they're introduced and when they get patched, things like that. The reason why this is so important is because these like wide sort of ranging vulnerabilities are quite easy to exploit. So you've ever heard of a tool called Metasploit? It's like a pen testing tool, and you can just, it's really fun, like really cool to use actually, because you sort of type in a certain type of vulnerability and you point it to a server if you have access to like a local port, and it will just like print out whether it's executable or not and just automatically run it. Like I did one on like a little demo server where I just like ran one for like an outdated version of a PHP framework, and it just, you press run, I typed in the IP address, and it just got me into the server, and I just had like full access to it. And yeah, so it's really important just like keep your dependencies up to date. Second one we're going to be looking at is SQL injections. So I've got 2 types on here. I've got like bypassing authentication, which is first. So yeah, this is like pretty standard login box. And I've got the second part down where it's got the SQL query, select star from users where username equals blank. So this is what it would usually do. But if we type in the input at the top, we can change this SQL query to close the input. Then, so that will close the username input. So we'll just search for an empty string, like as in this SQL query here, and then say or 1 equals 1, which obviously always equates to true, and then comment out the rest of the password bit. So the SQL query will now print select star from users where username equals nothing or 1 equals 1, and we'll just log you in. Or just like fetch it. Yeah, that's like one type of SQL injection. And the second type we have is batch statements. This is sort of like classic one you may have seen before, where you're just closing the SQL statement and just running a new one. This is quite often used. I mean, if you manage to get this, you can pretty much do anything on the database. So here we have one that's like a denial service, just like wipe the database and drop the token users. But you could also use this to print out anything from the database, and yeah, obviously breaking confidentiality and integrity. So the important part of this is that we have the semicolon in the middle of after the username, and that's telling the SQL query that a new one is starting, and then it will just run the next one. Cool. So looking into how we can actually fix SQL queries or prevent SQL injections. So you want to not use plain SQL when you can. So you can either use prepared statements or stored procedures. So prepared statements are a method of pre-defining queries that get pre-compiled in SQL code. You can leave out unspecified parameters and then bind them at the execution of the statement. And then the way that the statement is compiled will prevent any ejections from being possible. Just if you're passing in only the variables, and then it's done in such a way that the database is kind of already aware of it. And then stored procedures are quite similar, but stored on the database and can be reused through sessions. So yeah, both of these are sort of like similar. They have like different costs and benefits in terms of like performance, but both should help you prevent SQL injections. And also you can use things like ORMs just to reduce the need on using like plain SQL or just running SQL query in general. Next thing is you just want to escape all user inputs on the client and server side. So just running on the client side isn't enough because you can just edit requests and send it however you want. So you need to make sure that all inputs are escaped, like when they're crossing like the boundary of like the client and server. And then also you want to apply the principal least privilege. So this is ensuring that, like the lowest amount of privilege is given to anything. So if it doesn't need full access to a database, you don't allow it. And that just means like if something ever goes wrong, that it should be protected from that in some way. And then also on to apply this into the modern web, where we're not often typing lots of plain SQL queries anymore. We're using things like GraphQL ORMs. And I think the problem with these in terms of security is it often gives developers more confidence because you're not really typing SQL queries as much. You kind of just assume that it's going to be safe and you kind of get a bit more confident. But that's, especially if you're just using GraphQL, it's not always the case. And like you will end up sometimes with more complex queries having to write SQL, and you need to make sure that when that happens, you're sort of ready for it. So yeah, I'm specifically applying this GraphQL just because I used it. I don't know if it's similar things other people use. But yeah, you want to make sure that all data types are scalars are renumbered from GraphQL or having custom ones. And you want to define schemas for all your mutations. So this is using the input keyword in GraphQL, just ensuring the right types are being passed into the query. And then rather than creating a list of blocked characters, we often advise to create a list of allowed characters in your sort of queries in GraphQL. So this just means that, you're just blocking more and you're not going to like let anything slip through. And another important thing is when you reject inputs, that you don't just print out the whole sort of error message out to the user, because like pen testers or actual malicious third parties will sort of use this information to sort of find out more about your system and like how validation works, and from that they can sort of work out other ways to sort of like pivot the attack into something that actually works. Cool. So next we have cross-site scripting. So cross-site scripting is a malicious injection of code into a trusted website, which is then run by the user. So this is usually code that's coming that isn't really meant to be run on the server. It's coming from like a third-party source or just like direct from a database, but it's been sort of put there by a malicious actor. And it's just run on the user's computer without them really knowing. So it can come from either the client or server. That's like the origin where it's coming from. So servers when it's including HTTP requests and it's coming to the user, or the client is when it's sort of supplied by the user's computer. So that could be like click on a link that sort of injects it into the site, things like that. So this diagram is quite good to show it. So this is an example of a reflected attack, I think. So the user clicks a link and that link will open the actual website, but it will load a malicious script with it. So you can sort of embed that into the link. And then that's then run on the website. And in this case, it's sending private data to the attacker. So I'm going to jump into a bit of demo on cross-site scripting, just to sort of give you a bit of an idea of what's happening. So here we have just a very basic website, has a search box, and you type it in, type search, and it will search and print out the query here. So what we might want to do is try to we might want to try and inject an attack into this. So what we might want to do is just print this image, which will error, and then print an alert to the screen once it errors. You can put it in the search box, unfortunately it doesn't work because this site does URL encode the query. But if we are to encode it ourselves first, we get this string, which we can then place as the query parameter. And it will print out our image, and it will not find this image because it does not exist, and it will then go to this error code and run this alert. So obviously this is kind of like what a pen tester would do, just show that it's possible to like run any arbitrary code. But I think it would be quite cool to show something a bit more fun with it. So one thing we can do is this site does implement cookies. So we can see we've got a session cookie here. And if we run a different script, so this one will do the same thing with an image where error, and then it will then look for the cookie and then send it to a server that are like malicious actors running. So we copy this. This is running code, and it prints out the image again. And if we go to this server, we can see that this cookie has just been sent over to the malicious actor. So from there, someone can just like steal your session, log in as you, and pretend to be you. And then other things you can do are, well, this one is the keylogger. So it will just try and work out what you're plugging and just send it over to the server. So we go here, type this in. So if I type my password, it should send it over. Yep. So it sends it over to the server, and now whatever you type into the website is now just free information for this typo. So we want to now just look a bit into cross-site scripting on the web, because React does do a good job of protecting us by default. Like when you use JSX elements, it will automatically escape and everything. But there are like some things you need to watch out for, such as when you're appending to just an HTML element, you're not getting the free what's it called? Like escaping that JSX will do. So you want to make sure you use a library like DOM purifier for any HTML data that you're running there. And things like create ref, when you get a direct reference to your HTML object, that's when you can start actually injecting scripts into your code. So yeah, just be aware of when you're accessing things directly like that. So yeah, countermeasures for this are treating all external data as potentially malicious. That means escaping all the time whenever it crosses like application boundaries, or when it could come from like a link. And then you also want to use content type headers in your responses to ensure the browser interprets data correctly, because browsers are smart enough to like know what data should be doing and all automatically apply things to keep it safe, but you need to make sure the headers are there. And then things like setting inner HTML dangerously, setting inner HTML for React is ways that you can end up doing this. The next thing we're going to look at is cross-site request forgery, or CSRF. So this exploits vulnerabilities in cookie-based session handling and forces you to carry out unintended actions. So how this works is usually on a website, it will have a link that will send you to the legitimate website, but within that link, it will have like scripts that will run code. So this one, for example, if you click this anchor tag at the bottom to go to this link, it will run this post action to this other website called vulnerable website, and it will update the account with the new details. And because you're going to a legitimate site, it will use your session cookies, and then the real site will think that it's you, and will just run it without sort of checking. So we have another demo for this. I'll just have to switch this over. So we go to this one now. We have a little movie website where we can add a review. Currently we're not logged in, so if we submit, like nothing will happen. But if we get a session cookie and log in, we'll now be logged in, and we can add a review to this film. So now, it's added this comment. We're logged in as the user Alice, and it saves it there. We go to our profile, we can do something like edit it. I'll change it to Robbie and press save. Now when we go back, it will have updated our details. Just sort of saving this on the server side. So what happens is someone could be on, probably shouldn't fall for this website, but if it looks a bit more legitimate and you think, oh, I'm going to click this link and go to this website, what we'll do is you'll click this and this will execute that the form script that I had on the other page, and it will update our details to be the attackers. And it takes us over and our details have already been updated. If we don't click save and I just go to home, we'll see that it's already updated and we've now lost our account essentially. Like, obviously this is just changing email and username, but if you change someone's email, you can just go in and reset the password. Or if this was like a banking app, you could be sending like transactions through this. So we look at countermeasures. We can use something called a CSRF token. And this is a very large randomly generated value that is sent to a user. So this happens on the initial HTTP request, and it's not per session. It's it's just stored in the user's browser, and it's sent from the from HTML. And that means that they need to have this token in order to send it. So it's coming from a different origin. Then the server will see that it doesn't have a valid CSRF token or reject a post request. Yeah, so there's a bit of code on here just to sort of demonstrate that. It's sending CSRF header and sending it with the post request, and then checking it.
How does this differ from just that implementing token-based, like a token-based authentication?
Like compared to a session cookie?
Yeah, it seems like you're like taking a sessions-based approach and then putting a token onto it.
So sessions are sort of like persistent. So once I close the website, I'll save my sessions. When I open the website again, I'll have that session. Whereas this one, it doesn't really care about your account. It just sends this randomly generated thing with your request. Like when you first go to the website, I'll send it with it. And then during that like, try not to use the word session because that's like confusing, but during that sort of like use of the website, you'll use that token. And then when you get another page, it will have a new token. Okay. So it's only once you're like actually on the page.
Every single endpoint of yours would, every single like endpoint that takes a post request would need to have this.
Yeah, I think so.
Okay.
Yeah, so looking at it in the modern web, we now use cross-origin resource sharing, which is like a new method of sort of allowing requests from external parties to come in. So this is like adding like an extra bit of complexity to it. So this always requires a pre-flight request to be sent. So I think, yeah, applying this to modern web is just ensuring that like your GraphQL or whatever you're using just has the required like settings to use this. So for example, this is an example for GraphQL where you require the pre-flight to be there. Yeah. So what CORS does is allows server to indicate origins other than itself to allow browser to load resources. Yeah, and the reason why this is important to add this is like some really simple requests don't actually require this pre-flight, but an attacker can use these simple requests in order to start running CSRF attacks. And that's why you need to always like have it fully required, otherwise you'll be vulnerable from this. Yeah, that brings us to the end. So I'm just going to go a quick recap. So software vulnerabilities can be extremely expensive for companies, both to your own clients, and also we have a moral responsibility to protect our users from malicious actions. So our code needs to ensure that common vulnerabilities cannot be exploited. I think key takeaways are to treat all external data as potentially malicious. We need to sanitize and encode all external data, and always apply the principle of least privilege whenever possible. And I think some next steps for anyone that's sort of interested in looking into this further is to get familiar with the OWASP top 10 vulnerabilities, just reading that page and seeing all the different sort of advice they have on there and all the different vulnerabilities are. Yeah, that's it. Thank you.